All right, today we are diving into something really cool. A blueprint for building AI you can actually trust. And I mean really trust, especially when the stakes are sky high.
So let's just jump right in with a question for you. Imagine this. Your job is to build an AI, but here's the catch. Its work has to be flawless, like zero room for error. None. How would you even begin to tackle that?
And look, this isn't some abstract puzzle. This is a real-world problem. We're talking about automating the French R&D Tax Credit report. And you got to understand, this isn't just some boring paperwork. It's a legal document that has to be perfect. If you mess this up, you're looking at some serious, serious financial heat from the government.
So how did they pull it off? Well, it wasn't with some magic black-boxed algorithm. Nope, it was with a carefully crafted blueprint, a set of design principles that make sure the AI is reliable, controllable, and, most importantly, trustworthy. So let's break it down.
Okay, first things first, let's really get a handle on the job itself. We are talking about a seriously high-stakes AI challenge here. The goal? To automatically create these super complex reports that have to be completely bulletproof when a tax auditor comes knocking.
You know, this AI's job description is, well, it's massive. It has to go out and pull data from all these different places: Jira, GitHub, Confluence. Then it has to actually analyze source code, go read academic literature to figure out the state of the art. And then it has to mush all of that together into one perfectly structured audit-proof report. I mean, what a complex job, right?
So the big question is, how on earth do you control a tool that powerful? Well, that brings us right to the heart of this blueprint. The core idea, and this is brilliant, is to build a rigid, unchangeable skeleton for the report before you let the AI get creative.
And they do this with a really smart 4-layer architecture. You've got the rules up top, then the step-by-step workflows, then the specific instructions for the AI, and finally, the code that does all the heavy lifting. Now, this separation, it's the secret sauce. For example, when they needed to add a new rule about the quality of evidence, they didn't have to touch the code at all. They just updated the instruction files. It's a fantastic approach.
This brings us to maybe the most important principle of all. Script first, AI second. See, a lot of people think you just give the AI a blank page and say, hey, write me a report. But that is so risky. The structure gets all wonky, it drifts from the format, you totally lose control. But with this method, the script is the architect. It builds the perfect, solid foundation. Then the AI comes in as the interior designer, to add the beautiful, high-quality narrative in all the right places.
So how does this actually work, like under the hood? It's pretty cool. A deterministic script builds the entire structure of the report, but it leaves these special little placeholders, these AI-enhanced markers, in the exact spots where it needs the AI to step in and write something. And these markers aren't just empty. They contain super specific instructions, telling the AI exactly what kind of text to generate right there.
And get this. The team that built this was not messing around with this rule. The documentation literally says, in bold, you must run the generator script first. Never skip it. No exceptions. Why? Because that's the only way to guarantee the report's structure is perfect. Every single time. That script is the ultimate source of truth for the format.
All right, so we've got the structure locked down. That's great. But what about the actual content? I mean, how do you stop the AI from just making stuff up? The hallucination problem? Well, that's where the guardrails come in. This is all about programming the AI to be honest and, crucially, to prove its work.
The core idea here has a name: evidence discipline, and it is completely non-negotiable. What it means is that every single claim the AI makes, every single one, has to be traceable right back to the original source data, whether that's a Jira ticket, a line of code, whatever. If there's no evidence, the AI can't make the claim, period. And they built this in using 3 really clever techniques. First, they actually let the AI say, I don't know. If it's not sure, it just drops in a little limited evidence marker. Second, and this is huge, they force it to ground its claims by using direct quotes from the source data. And third, if the AI makes a claim and then realizes, oops, I can't actually back this up, it's programmed to retract it, leaving behind these empty square brackets as a little flag for the human reviewer. So here's the bottom line. The goal for a perfect report is to have 0 of those empty bracket markers.
A score of 0 is a perfect score. It means every single claim that the AI generated was successfully backed by cold, hard evidence from the source material. It's a real, tangible way to measure if you can trust the output. Okay, so with control and honesty totally locked down, now it's time for the fun part. It's time to unleash the AI's superpowers. Let's look at how they made this thing not just trustworthy, but also incredibly fast, powerful, and smart. Think about it. A process this complex could be painfully slow, right? Well, the solution they came up with is called multi-agent parallelism. It's a fancy term, but the idea is simple. Instead of having one AI do everything step by step, you have a whole team of AI agents all working on different parts at the same time. And they do this at 3 different levels, which is wild. At level 1, you've got agents pulling data from Jira, GitHub, and Confluence all at once. Then, at level 2, if a project has, say, 5 code repos, you get 5 different agents analyzing them all in parallel. And then, get this, at level 3, while you, the human, are just starting to review the draft, another agent is already working in the background doing academic research. It's like having this amazing, hyper-efficient team of researchers working for you. So that's speed. But how do you make the AI smart? How do you teach it what a good report actually looks like? Well, you don't just give it rules, you give it examples. The system has access to 6 real successful reports that have already passed audits. So before it even starts to write, it studies a couple of these to calibrate everything, its tone, its structure, even the word count, all based on what's already been proven to work. But, and this is such a critical lesson, the original creators of this warned that the AI, in this case Claude, learns flaws faithfully. What does that mean? Well, in an early version, their example reports had some formatting mistakes. They used bold text where they should have used proper headings. And guess what? The AI immediately started copying that exact same mistake. It's the ultimate garbage in, garbage out scenario. Your AI is only ever going to be as good as the examples you feed it. So let's zoom out for a second. We've been deep in the weeds on a very specific case study, right? But these techniques, they're not just for writing tax reports. They're basically a universal guide for building any kind of serious AI that you actually need to trust. So if you're going to remember anything, remember these 4 big takeaways. Number 1, separate your rules from your code with a layered architecture. Number 2, always use the script first, AI second approach. Build that deterministic skeleton first. Never start with a blank page. Number 3, demand evidence discipline. Make your AI prove everything it says. And number 4, your AI is a mirror. It's only as good as your examples, so make sure those examples are absolutely pristine. Really, the biggest takeaway from all of this is that trustworthy AI isn't magic. It's not about finding that one perfect, magical prompt that solves everything. No, it's about engineering. It's about craftsmanship. It's built with deliberate layers, strong guardrails, and an absolute commitment to control. And that really leaves us with one final big question to think about. As these AI models get more and more powerful, and they are, exponentially so, we really have to ask ourselves, shouldn't this be the standard for how we build them? Shouldn't this level of rigor, this control, this demand for proof, shouldn't that be the default? Especially for any AI job where the stakes are this high?